This is Design Team 64's design pitch from the Client Team 63 for a back scratcher. In the description slides provided by our client, we had to develop a back scratcher that was collapsible and had the ability to be mounted on the back of a typical chair. It would scratch automatically, be lightweight and cheap and easy to store, and it would require a user input to start. During Task 2, several questions were asked. How much of the back needs to be scratched? The client had no particular preference and said as long as the back scratcher was effective and completed the task to an extent it was acceptable. How long should the scratcher be performing the task? The client also left this to our discretion, and our back scratcher scratches infinitely until the user turns it off.
The design specifications for our back scratcher were first that the customer wanted the device to be collapsible, lightweight, cheap, and continue for a set amount of time. So in order for the device to be collapsible, we had the size of the device after collapsing needed to fit within a 1 feet cubed box, and that's also what we got our final back scratcher to be. It needed to be lightweight, so we wanted it to be weigh less than 5 pounds, and our target value was 3 pounds. In order for it to be cheap, we wanted to use the least amount of Lego pieces as possible, particularly under 50. So we aimed for 30 individual Lego pieces. And then continue for a set amount of time. We wanted it to be greater than 5 minutes, and for this we had our back scratcher run for infinite time until the user turned it off. Some additional requirements was that they wanted the design to be started by human input, mountable on a chair, and scratch automatically. So for our design, in order for it to attach to the chair, we had a sort of hook idea, as you can see on the top, and we wanted to have the hook attached to the chair. And then in order for it to scratch, if you look at the diagram on the right, you see the motor in green, and you would have like a peg-like structure that would attach to the scratcher area and the motor, and the scratcher would move left and right.
For the scratcher to move automatically, we created a short program on the BrickPi. Basically what it does is once the user starts the program, it would make the motors rotate forward and backwards infinitely. And it will run infinitely until the user ends it.
So when we were constructing our final design, there was one big question we had to answer. How are we going to define a scratch? The vagueness of this task allowed an infinite amount of possibilities. So there were several options that we considered. First off was a bit of a train wheel design. Basically, we would have the motor spin a larger wheel, and to that fixed point, we would attach a beam connected to our actual scratching hook. Now, this would allow the radial movement of that fixed point it's attached to oscillate the actual scratch up and down or side to side, depending on how we attach it. While this might allow for some flexibility, it would have been incredibly difficult to actually implement, because we'd have a lot of weight fixed on one point. We'd have to have a lot of stress on the motor, and then attaching it all together would have been a little bit more difficult than we wanted. So the second option that we considered was a bit of a pendulum style motion. This is what we chose as our final design. Basically what we did, again, we had a similar concept to the first option. We would have the motor spin a wheel, but we fixed our beam to 2 different points along the diameter of that wheel. We would then have it rotate at a fixed amount of degrees back and forth, side to side, giving a little bit more flexibility and a bit more back scratching range. So this is a video of our back scratcher actually in action. As you can see, it rotates back and forth infinitely. Once the user plugs in the battery pack, you're good to scratch. If you want to stop it, simply unplug the battery pack. This allows you to get the most out of your back scratch and not be limited by a set duration of time. One of the things that you'll notice here on this design is the placement of the battery pack. Well, gee, why did you just place it on top? Well, it was because of weight distribution. Actually, on the back is our actual Raspberry Pi, and that acts as a sort of counterweight to the motor and the pendulum on the other side of the chair. However, what the battery pack does, it further adds a necessary force downward onto our little hook in order for it to actually clamp and make better contact with the chair. So one of the final requirements is that it had to be fairly easy to take apart. So here's a video of that process. So first, we take the battery pack, we remove a safety bar to keep the pendulum on. Then we remove the pendulum piece, the motor attached to the wheel, and you're all good to go. You can even see the little bit of the hook structure that we made with the Raspberry Pi. To put it back together, simply plug in the motor, attach it to the beam, attach on the pendulum, add the safety bar, and you're good to go. Overall, this design was a great success, and not only did it meet all the specifications, but it gives an absolutely amazing high-quality back scratch.